On May 27, 1982, a cartoonist named Gary Larson published a Far Side comic showing a caveman standing at a lecture podium in front of a slide of a stegosaur's tail, pointing at the row of spikes and telling his audience, quote, "Now this end is called the Thagomizer, after the late Thag Simmons." It's a joke. The whole premise is that some poor caveman got killed by the spikes, and the fictional caveman in the comic named the body part after him. That's it. That's the entire origin of the word. And today, that joke isn't just a joke anymore. It's a real word used by real paleontologists appearing in real peer-reviewed scientific papers, describing a real piece of dinosaur anatomy that, before 1982, didn't actually have an official name at all. We're going to get to exactly how that happened, but it's honestly just the second strangest naming story attached to this animal, because the genus name itself, Stegosaurus, is also the product of a scientist getting the anatomy completely wrong and never quite living it down. Let's start at the beginning, because even the beginning of this animal's story is a story about misreading the evidence. In 1877, in the thick of the Bone Wars, the brutal, competitive scramble for fossils that also gave us Dimetrodon's own naming story a few years earlier, Yale paleontologist Othniel Charles Marsh named a new genus based on fragmentary material collected near Morrison, Colorado, by fossil hunter Arthur Lakes. What Marsh had in front of him was a handful of tail vertebrae, a single dermal plate, and some scattered postcranial bones, not remotely a complete skeleton. And working from that limited material, Marsh made a series of educated guesses that turned out to be wrong in almost every direction. He initially believed he was looking at some kind of aquatic, turtle-like animal, and specifically thought the plates lay flat across the animal's back, overlapping each other like shingles on a roof, comparing them directly to the shell plates of an extinct sea turtle. He briefly, and also incorrectly, thought the entire body might have been covered in small spines, based on some scattered cylindrical teeth found near the site, teeth that turned out, once properly sorted out a few years later, to actually belong to a completely different animal, the giant sauropod, Diplodocus, digging in the same formation. So the original description of this animal involved a wrong body plan, wrong plate orientation, and a case of mistaken dental identity, all at once. And the name Marsh gave it, Stegosaurus, meaning roof lizard, comes directly from that flat shingled plate misconception. Once more, complete plates were recovered, and it became obvious they actually stood upright, on edge, along the animal's back rather than lying flat across it. The anatomy got corrected. The name never did. Stegosaurus, roof lizard, remains the official genus name for an animal that, as far as anyone currently understands it, never had a roof-like arrangement of plates at any point in its existence. There's a smaller wrinkle in the discovery history worth knowing too, because even the specific fossil Marsh used to define the genus turned out to be a problem. That original 1877 material, formerly designated the species Stegosaurus armatus, is now considered too incomplete and fragmentary to reliably define anything. A genuinely dubious specimen by modern standards. The animal most people actually picture when they hear the word Stegosaurus, and the specimen the scientific community now treats as the genus's real reference point, is a different species entirely. Stegosaurus stenops, described by Marsh a decade later in 1887, from a considerably more complete, articulated skeleton found at Garden Park near Canyon City, Colorado, collected by fossil hunter Marshall Felch. The formal governing body responsible for zoological naming eventually stepped in and officially designated Stegosaurus stenops as the reference species for the whole genus, precisely because the original 1877 material Marsh actually named it from wasn't good enough to reliably represent it. So even the genus's own official reference point had to be quietly swapped out for a better fossil, decades after the fact. Now, the plates, because this is where the real, still unresolved scientific debate actually lives, on two separate fronts, and it's worth walking through both honestly, rather than pretending either one is settled. First, how were the plates actually arranged on the living animal? This took decades and multiple complete reversals to sort out. Marsh's original 1877 guess, flat and shingled, got dropped almost immediately once more plates turned up standing upright. His own revised 1891 reconstruction proposed a single row running straight down the midline of the back, but that version ran into a basic anatomical problem, since it's genuinely unclear how a single row of these plates would have embedded into the skin without badly overlapping each other at the base. That single row idea got picked back up in a modified form nearly a century later, in the 1980s, by an artist named Stephen Cherkas, who based his version partly on the dorsal spine anatomy of modern iguanas, but it never became the accepted scientific position. In between those two single-row proposals, a different arrangement took hold for decades instead, a paired double row, left and right plates sitting directly across from each other, mirror images down either side of the spine. That's the version you'll see in Charles Knight's influential 1901 illustration, and it's the version that shows up in the stop-motion Stegosaurus in the original 1933 King Kong film. But that arrangement has its own problem too, once you actually look closely at fossils where plates were found still partially articulated in position on the animal's back. Multiple specimens of Stegosaurus stenops, including the species' own reference skeleton, preserve plates in a pattern that isn't paired at all. It's staggered, two rows running down the back, but offset from each other rather than mirrored, so that a plate on the left side doesn't line up directly across from a plate on the right. Paleontologist Charles Gilmore argued for exactly the staggered arrangement as early as 1914 against the paired row model that was standard at the time, and it took until Kenneth Carpenter's detailed 1998 study, later reaffirmed by Peter Galton in 2010, for the staggered double row to become the currently accepted model, based directly on fossil evidence rather than artistic guesswork. It's a genuinely strange detail once it sinks in. This animal's plates weren't symmetrical down its own spine. You couldn't flip one side and expect it to match the other. 4 different arrangements, proposed across more than a century, before the fossils themselves settled the question. Second, and this one is genuinely still open, what were the plates actually for? The dominant popular explanation for decades has been thermoregulation, the idea that the plates function as heat exchange fins absorbing warmth in the morning and shedding excess heat later in the day. An idea formally proposed in a 1976 paper, published in the journal Science, that made the cover of the issue, and shaped how this animal got explained in textbooks and documentaries for a generation afterward. Later histological studies in the 1980s found networks of vertical, pipe-like channels inside the plates, initially read as supporting evidence for exactly that kind of active blood flow-based heat regulation. But more recent, more detailed research has pushed back hard on that interpretation. Kenneth Carpenter, working through the late 1990s, pointed out that if the plates were a specialized heat-regulating organ, you'd expect to see that same adaptation showing up consistently across the broader stegosaur family, animals of similar size living in similar environments. Instead, other stegosaur relatives have plates of noticeably different sizes and shapes, some much smaller, which doesn't fit a story where the plates exist primarily to solve a shared, universal heat management problem. Later studies through the 2000s and into the 2010s, looking more closely at the internal channel structure of the plates, found that the same basic vascular pattern shows up broadly across armored dinosaurs generally, including ankylosaurs, which suggests it isn't a specialized thermoregulatory adaptation unique to Stegosaurus at all, just a fairly ordinary feature of how this whole broader group of dinosaurs grew bony armor. That's pushed a real shift in expert opinion toward display, species recognition, attracting mates or intimidating rivals as the more likely primary function, especially once researchers confirmed from a fossilized keratin sheath impression found on a plate that these structures were likely covered in a horn-like material in life and quite possibly brightly colored or patterned, the kind of feature that makes a lot more sense as a visual signal than as a subtle internal thermostat. As of right now, the honest current summary is that most specialists lean toward display as the primary driver, with thermoregulation treated as a secondary, possibly incidental benefit, riding along on a structure mainly shaped by something else, rather than the other way around, which is close to a full reversal of the popular explanation most people grew up with. But it's genuinely not a close question. Some researchers still push back on parts of the display hypothesis too, and a very recent, not yet peer-reviewed study is currently re-examining whether plate-shaped differences between individuals reflect male versus female differences specifically, a claim that remains statistically contested as of this recording. The honest answer to what these plates were for is still being actively argued about by the people who study them for a living. Now, back to the Thagomizer, because we've set up the joke, but not the part where it became genuinely, professionally real. Before Gary Larson's 1982 comic, the spike structure at the end of a Stegosaurus's tail simply didn't have a dedicated scientific name. It was just, colloquially, the tail spikes. Larson's joke term sat around as a piece of pop culture for over a decade before paleontologist Kenneth Carpenter, working at the Denver Museum of Nature and Science, started using Thagomizer from the podium while presenting on a fossil at the Society of Vertebrate Paleontology's annual meeting in 1993. It caught on gradually, first informally among working paleontologists, who clearly appreciated the joke. Then more broadly, the Smithsonian Institution uses it. Dinosaur National Monument uses it. It's printed in the Complete Dinosaur, a major academic reference text. It showed up in the BBC documentary Planet Dinosaur. And over the past decade and a half, it's genuinely crossed over into peer-reviewed scientific literature itself, appearing in published papers on Stegosaurus biomechanics, on a completely different, distantly related armored dinosaur called Stegosaurus described in Nature in 2021, and in several other papers through the early 2020s. It's worth being precise about what that does and doesn't mean. Nobody ever published a formal paper establishing Thagomizer as the official anatomical term, the way a genuinely new scientific term normally gets locked in. It remains technically informal jargon, but informal jargon that the Smithsonian uses, that shows up in Nature, and that most working paleontologists reach for by default, is informal jargon and name only at this point. A word invented as a punchline about a fictional dead caveman is now the word actual scientists actually use, out loud, in actual conferences, to describe an actual piece of dinosaur anatomy. And there's genuinely no other case quite like it anywhere else in paleontology. Which brings us to whether that tail weapon actually got used the way its name implies. And here, the fossil evidence is about as direct as it gets. A 2001 study led by Christopher McWhinney found a notably high rate of trauma-related bone damage and chronic infection, specifically on the spikes themselves. Exactly the kind of injury pattern you'd expect from repeated, forceful impacts, rather than incidental wear. And a separate, closely related 2005 study, led by Kenneth Carpenter, found something even more specific. An Allosaurus tail vertebra recovered with a puncture wound punched directly into one of its side projections, a wound whose shape and dimensions match the cross-section of a Stegosaurus tail spike closely enough to be considered a genuine match. Critically, that wound shows clear signs of partial healing, meaning the Allosaurus survived getting stabbed by a Stegosaurus tail and lived long enough afterward for the bone to start repairing itself. That's about as close to catching a specific fight between two specific dinosaur species in the fossil record as paleontology generally gets. The same broader study also documented a Stegosaurus neck plate carrying a U-shaped wound consistent with an Allosaurus bite, evidence running in both directions, a predator that got hurt by its prey's tail, and prey that, at least once, still ended up bitten anyway. There's one more piece of long-running misinformation about this animal worth clearing up properly, because it's stuck around in popular culture for close to 100 years now, and its correction has its own and unsurprisingly long history. In 1881, Marsh himself described an unusually large, hollow canal running through the sacral vertebrae, the bones around the hip region, noting it was actually larger than the animal's own cranial brain cavity, and referred to it, in his own writing, as something like a posterior brain case. That single offhand description eventually snowballed, helped along by early museum mount discussions in the early 1900s, into the popular myth that Stegosaurus had an actual second brain near its hips, controlling the back half of its body independently, since the real brain up front was assumed to be too small to run the whole animal on its own. It's worth knowing that scientists have been actively correcting this myth for a genuinely long time, not just recently. Paleontologist Barnum Brown explicitly disputed the second brain claim in a 1932 article discussing the American Museum of Natural History's own Stegosaurus mount, nearly a century ago at this point. And the science is entirely clear today. No dinosaur, Stegosaurus included, ever had a functioning second brain made of actual neural tissue. That's fully settled. What's genuinely still open is what that enlarged hip canal was actually for, since it's a real, physical structure, not an invented one. The leading current hypothesis, championed by researcher Matt Weddle, is that it likely housed something called a glycogen body, a structure that also shows up in the hip region of modern birds, thought to store glycogen, an energy-rich carbohydrate. It's worth being honest about the limits of that explanation too, though, since researchers don't fully understand what glycogen bodies actually do even in living birds today. So calling this the answer overstates how settled it actually is. It's the best current hypothesis, not a fully solved mystery. As for the animal's actual brain, up front, where brains are supposed to be, it really was small, estimated at somewhere around 65 to 80 cubic centimeters in an animal that could weigh several tons, roughly comparable in absolute size to a dog's brain, on a body many times a dog's size. The popular walnut-size comparison oversells just how small it was in absolute terms, but it's roughly right about how small it was relative to the rest of the animal. So, what was all of that brain, small as it was, actually directing this animal to eat? Stegosaurus was a low browser, built with a short neck and a low-slung skull, well suited to feeding on ferns, horsetails, mosses, cycads, and conifers. The low-growing, non-flowering plant life available in the late Jurassic, generally foraging within about a meter of the ground in its default four-legged stance. There's genuine debate over whether it could rear up onto its hind legs, using its tail as a kind of tripod support, to reach considerably higher vegetation, a behavior Robert Bakker has argued for, and Kenneth Carpenter has pushed back against, and a 2010 biomechanical study found support for rearing behavior in a closely related stegosaur called Kentrosaurus, without confirming the specific tripod tail mechanism for Stegosaurus itself. Genuinely unresolved, not a settled behavior. Its mouth had no front teeth at all, relying instead on a horn-covered beak, similar in basic concept to a turtle's, with small, flat triangular cheek teeth, further back showing wear patterns consistent with actual grinding rather than simple slicing. And the actual strength of that bite has been revised significantly in recent years. An earlier biomechanical estimate put the bite force at a fairly modest 140 to 275 newtons, depending on exactly where in the jaw you measured, less than half the bite force of a Labrador retriever, suggesting real difficulty handling branches much thicker than about 12 millimeters. But a more detailed 2016 study, using a full 3D scan of the skull of a particularly well-preserved specimen, nicknamed Sophie, held at the Natural History Museum in London, found the actual bite was considerably stronger than that earlier model suggested, comparable to a modern cow or sheep, and notably stronger than two other plant-eating dinosaurs measured in the same comparative study. That revised figure suggests Stegosaurus could plausibly handle tougher, woodier food, including cycads, and may even have played a role in dispersing cycad seeds through its diet, a meaningfully more capable eating machine than the earlier, weaker estimate implied. And now, the most recent chapter in this animal story, one that's still actively unfolding as of the last 2 years. And it has nothing to do with new anatomy and everything to do with what happens once a genuinely exceptional fossil leaves the ground. In May of 2022, commercial paleontologist Jason Cooper discovered a Stegosaurus skeleton on private land in Moffat County, Colorado, part of the same Morrison Formation that's produced this animal's fossils since Marsh's original 1877 find. Excavation continued through October of 2023, and what came out of the ground turned out to be the largest and most complete Stegosaurus skeleton ever found. 254 of the animal's roughly 319 bones preserved, standing 3.4 meters tall and stretching 8.2 meters long, roughly 150 million years old, including preserved throat ossicles and impressions of its actual neck skin. The skeleton, nicknamed Apex, shows signs of advanced age, with fused sacral bones suggesting a degree of arthritis, and no evidence of predator attack or combat trauma anywhere on the body. an animal that appears to have simply lived a genuinely long life and died of something else entirely. In July of 2024, Apex went up for auction at Sotheby's in New York. Pre-sale estimates put its value at somewhere between $4 and $6 million. It sold for $44.6 million to Kenneth Griffin, founder of the investment firm Citadel, making it the most expensive fossil ever sold at auction, and the first Stegosaurus skeleton ever to go under the hammer at all. That sale price didn't land quietly within the paleontology community. Multiple prominent researchers, including the vice president of the Society of Vertebrate Paleontology and paleontologist Steve Broussat, publicly raised concerns about one of the most scientifically significant fossils found in decades, disappearing into private hands rather than going to a research institution where it could be freely, permanently studied. Griffin did loan the skeleton to the American Museum of Natural History, where it went on public display in December of 2024 under a 4-year agreement, alongside funding for a postdoctoral research position specifically tasked with determining Apex's exact species and building the first detailed Stegosaurus growth curve using bone histology. But the underlying tension hasn't fully gone away. In June of 2025, the Society of Vertebrate Paleontology sent an open letter directly to the museum, raising concerns that there's no binding, long-term agreement guaranteeing continued scientific access to the specimen once that 4-year loan eventually runs out. As of right now, that's still an open, unresolved point of friction, not a settled arrangement. A genuinely current example of science and the private fossil market pulling in different directions over the same physical object. So, an animal named after a complete misreading of its own most famous feature, a name that stuck for nearly 150 years despite everyone agreeing it's wrong. A weapon on its tail that had no real scientific name at all until a cartoonist made one up as a punchline. A name that took over a decade to cross from joke to conference podium, to actual peer-reviewed paper, and somehow never once got formally, officially, made official along the way. 2 separate ongoing scientific debates, one about how its most distinctive feature was even physically arranged on its own body, one about what that feature was actually for, both taking well over a century to get even this far toward an answer. A hip structure mistaken for a second brain for the better part of 100 years, with a correction that's been publicly stated since at least 1932, and still hasn't fully caught up with the popular imagination. A bite force that got recalculated stronger, once someone finally built a proper model instead of guessing. And, as of the last 2 years, the most expensive fossil ever sold, sitting at the center of an argument about who actually gets to study it, that's still being negotiated in real time. Almost nothing about this specific, extremely famous dinosaur is actually finished being figured out. Alright, since today was apparently the day for animals whose defining features got badly misread the first time around, next time we're going even further back in the history of paleontology itself, to one of the very first dinosaurs ever formally named, and a mistake so specific it's become one of the most famous illustrations of how fossil reconstruction actually works. Iguanodon and the single curved bone that got mounted on the wrong part of its body entirely for decades. A mix-up that connects directly back to Richard Owen, the same paleontologist who showed up in our Basilosaurus episode, correcting an entirely different animal's identity. That one's next, and it's going to be a long one. Let me know in the comments what you want cataloged after that, and subscribe to ClawCatalog so you're here for it.